material. I'm going to try to explain to you essentials of the topic, even though there's a lot of ground to cover. And since there's so much to do, please keep your questions for the end. In order to help for that, each slide is numbered. So if you have a specific question to a specific slide, just write down the number so you can tell me afterwards. And please only ask questions if it's really, really important or you think that it's just for clarification. With that being said, so I'm going to give a bit of overview and context to the essential issues. I'm going to go into two specifics of academic theory concerning ecology that I think might be useful to know about, specifically social metabolism theory and industrial ecology. And I'm going to talk to you about ecological economics. And we're going to round it up by seeing applications in debating with stakeholders and ideologies, and perhaps, if you're in the mood, emotion. So, overview and context. Most obvious case when we're talking about climate change is, well, the CO2 emissions and the greenhouse gas emissions. For a bit of context, you can see here observations since the 1750s, and they have literally skyrocketed. You can see that also these emissions have been dominated by mainly the United States and the European Union as a whole, so all member state countries, with China coming third, and then several others such as Russia or even Japan. But you have really a very strong concentration of emissions within those key players. However, what is often overlooked is that CO2 emissions are not the only place to be concerned. So in a recent work done by Rockstrom and al., you have these planetary boundaries which have been highlighted and categorized with, below the boundary of safe emissions or safe changes, in zones of uncertainty with high risks, high consequences for the planet, and beyond the zone of uncertainty. And this has been reached for the biosphere integrity, for phosphorus emissions, and for infringing upon the nitrogen cycle. So this is not the only thing we need to talk about when we're talking about climate change. You can look at the loss of species, loss of biodiversity. You can look about how interventions in the nitrogen cycle cause things like acid rain, these types of damages. Same thing with certain types of phosphorus pollution. And we can also see that in terms of land system changes, we are reaching the danger zone here as well. So seriously, quite a few things that we should, as a society, look at. Now for a few predictions and a few observations. So this you probably have seen before with the 2 degrees centigrade path, because so far there is no doubt about it, it's going to get warmer. And the only remaining question is by how much? 2 degrees centigrade is the commonly agreed upon goal, with a 3.5 degrees increase possible with the current national commitments. And if we do with business as usual, 4.5 degrees at least. At least because recent findings point out that because of the cumulative effect of climate change, certain greenhouse gases, for example, being released due to the permafrost thawing, etc., we could have thawing as high and temperature rises as high as 7 degrees centigrade, which would be, and I quote, a game over scenario in terms of climate effects. So here is, in terms of comparison, 4 degrees difference, people might argue, well, that's not that much, but 4 degrees difference, that's half a mile of ice over Boston. 8 degrees difference, that's 200 meters sea level rise, that's no glaciers, that's palm trees almost at the poles. So when we're telling you that 7 degrees Celsius is possible, this is the time to get out the brown pants. Now, there has, of course, been significant reaction over the years in politics as to the climate issue. Here are a few key dates. So in 1979, we have the first World Climate Conference. In 1988, one of the key actors the IPCC, Intergovernmental Panel on Climate Change, set up. 1992, at Rio de Janeiro, we have the UN Framework Convention on Climate Change. We have, in 1995, the first conference of the parties. You might have heard of COP21 in Paris. This was COP1. 1997, famous COP3 in Kyoto with the Kyoto Protocol adopted by consensus, more than 150 signatories. The United States, interestingly enough, did sign the Kyoto Protocol, but the Clinton administration never sent it to Congress for ratification, and later on, well, we all know how that turned out with George W. Bush, etc. So, COP7 in Marrakesh, which had more detailed rules for implementation of the Kyoto Protocol, which were called the Marrakesh Accords. And in 2005, closer to us, at a more local level compared to that of the United Nations, you have the so-called European Union Emissions Trading System, or the ETS. This operated along a cap and trade, so there's a maximum set on the total amount of greenhouse gases that can be emitted, and you have a possibility of being granted allowances for emissions, and these can be then auctioned off or allocated and traded for by the different members and by the different beneficiaries. 2 years later, in 2007, we had the 2020 targets for the 2020 climate and energy package. What this means is that the EU promised that by the year 2020, it would attempt to reach a minus 20% on greenhouse gas emission and plus 20% and at least 20% of the percentage of energy in the EU coming from renewable energies. Other memorable dates, COP15 Copenhagen, notorious failure, with the Copenhagen Accord being only, yes, we should do something about climate change, we should limit it to 2%, but nothing binding. COP18 in Doha, with extension to the Kyoto Protocol and second commitment phase, starting on January 2013 and ending in December 2020. And then, of course, most recently, the COP21 in Paris with the Paris Agreements, adopted by consensus, signed by 93 UNFCCC members and ratified by 109, which was meant to provide global agreement, but also implementation strategies. So concretely, people signing this treaty, the countries signing this treaty, would promise to act in tangible ways, changes of legislation, etc. Interesting enough, it was refused by Iraq, Syria, Kyrgyzstan, and Nicaragua. The latter, though, Nicaragua, for reasons which might seem strange, they said that the Paris Agreements were a form of climate imperialism and that they didn't actually go far enough, and that this was just a smokescreen thrown out by the bigwigs in order, and that this wouldn't change anything, therefore boycotting the issue. Onwards to some academic theory. So when you look at climate change and what causes it, a place to start is to look at the environment and at the resource consumption of any given society. And this is where social metabolism and industrial ecology can be useful. So these theories highlight three different metabolic profiles for society. So you have the fundamental one being hunter-gatherers, using uncontrolled solar energy. Basically, the resources that they get, the energy they get, that's just, provided by the sun and by, nature's natural cycles. They are restricted by the land and by the biomass. They have no way to really shape their environment, with natural fluctuation, periods of hunger, just really working with what you got. In agrarian societies, you have more controlled solar energy system with the first use of technology to shape the environment and influence the chances of survival and of success of a community, with certain colonizations of ecosystems, domestication of animals and plant species, beginning of agriculture, farming, etc. And lastly, industrial societies, which shift from using the sun as a main source of energy to using fossil fuels. No physical restrictions, therefore, and accompanied by population and economic growth. Looking also at how the system is conceived, we see that it is the biosphere, the ecosystem, that is englobing the socio-economic system, highlighting the fact that the economy is not this thing that stands on its own, but it is part of the biosphere and cannot be treated as something independent. Here again, the whole point of social metabolism is trying to look at the inputs and the outputs, the way that the resources are being consumed in each different society, which is once again very interesting when we look at the recent histories since the beginning of the 20th century. So, in black you have the curve showing GDP growth. In blue you have construction minerals. In orange you have the fossil energy carriers such as oil, coal, etc. In yellow you have the ores and the more industrial minerals. And in green you have the use of biomass. So you can see that the number of billions of tons being extracted after being very stable moved on. And we have also diversified in the type of resources being used. As far as as early as the 1700s, we already were using carbon, iron. Now in the 1800s, we had we had copper being more heavily used. We had tungsten being used. And onwards and onwards, so with the 2000s, where we have, because of the sophistication of our technology, a reliance on rare earths, rare metals. So not only the quantity, but the quality of resource extractions has dramatically evolved. This means quite a lot, also for the European Union and for political and economic consequences. The EU is one of the regions that is most dependent on imports for metal ores. So you have here a list. For these first ones, 100% dependent on importations, and then 90%, and we do best with silver and chromite and aluminum with just under 50%. So when you think of the ecological consequences, you also need to think of the economic consequences, what ties together different countries, and what this means in terms of politics, in terms of negotiations, etc. and so on. You can also see that when we're looking at the producers, you have clear dominance for certain countries, such as China, such as the US and Brazil, but also Australia, where the mining industry is, well, everything's big in Australia. So across 19 types of resources catalogued in this paper by the Chatham House, the three largest producers account for 56% of global production. Here you can see also on the consumption side, which are the great consumers in the world right now, with a comparison between the 1980s and 2008. So while in the 1980s China only accounted for 8% of global material consumption, it today accounts for 28% of it. Food for thought. Yes, again, the diversity in material footprint and water footprint, carbon footprint, depending on regions. So not everyone is equal in terms of responsibility and in terms of damage to the environment. Depending on the level of your industry, depending on the type of economy that you might have vastly varying influences and effects. Now, as a consequence of this, you've had several attempts by economists to try and mitigate or find solutions and explanations. Now, one of the things that we have seen is the so-called environmental Kuznets curve. The Kuznets curve is the idea that a society goes through a transition period where inequality rises, and then once it reaches a certain point of development, after that point, the society will keep the economy will keep growing, will keep developing, but inequality will fall back. So it's comparable to demographic transitions. Here, the same concept is applied to the environment, where the assumption is that in pre-industrial economies, up until a certain point, you start polluting more and more, but there is a peak, and after that peak, you again become more efficient, and your economy still grows and still progresses, damaging the environment far less as a consequence. This is one of the theories. It is fairly controversial and has been, well, subject to many an academic and a political dispute over the years. answer to the scenarios linked to pollution have been relative and absolute decoupling. So the decoupling of environmental pressures and GDP increase. Relative decoupling would mean that you have a GDP increase, but also environmental pressures increasing, but at a lower rate. So the correlation becomes less and less important as time goes on, whereas absolute decoupling means that you have GDP growth moving onwards and environmental pressures decreasing simultaneously. The dream of green growth. One of the problems with that is the so-called rebound effect. What it means that when you have increased efficiency, it leads to decreased costs. It leads to the people who are now having new funds available, leading for them consuming more. For example, now you have Airbnb and car sharing making travel less expensive. So parts of the population that couldn't afford to travel suddenly travel far more. This has as a consequence that even though you can have green technology being implemented, the fact that people will then consume more technology as a consequence means that the offset, the benefits from having green technology might be far smaller than we think, and in some extreme cases even detrimental. Again, what the ideas of growth and of degrowth here being developed a bit further. So with degrowth, as we have, and we have this idea that the economy needs to actually shrink in order for us to have an actual positive impact on the environment. That this situation is so bad that we should, for example, revert to the standards of living we had in the 90s in Switzerland. There's a common reference. Now, this has been elaborated further upon by a scientist by the name of Victor. I will have references later on. And he categorized these different scenarios. So green degrowth, where in fact you have a decrease of intensity and of scale of pollution. Green growth, where you have the intensity of pollution declining faster than scale increases. Brown growth, etc., and so on. Self-explanatory from the graph. Now, this leads us to the field of ecological economics. So what the field of ecological economics does is, again, it frames the economy as part of the natural system, and with specific reference to the so-called entropy law, or the second law of thermodynamics. The basic proposition is this, that growth-based economic models are unsustainable because they're trying to achieve infinite growth out of finite resources, where every increase in the economy is an increase in disorder, in entropy within the economy, leading to the inevitable collapse of the system. It also rejects a fair number of the standard economic assumptions which you will see, such as value monism, the idea that, okay, there is one objectively good system of values that rational actors choose, therefore also rejecting the rational actor model, rejecting marginal analysis, meaning that, okay, using comparatives between units of, the advantage of one additional unit of production is not the good way to look at the economy, and criticizes a lot of the treatments of uncertainty and the analysis of market preference that you have as part of standard neoclassical economic theory being used in politics right now. So what it advocates for, generally speaking, is thus the inclusion of the physical costs of economic production, which we have been seeing with the whole industrial ecology and social metabolism slides early on, the biophysical and the social dimensions of the economy, application of precautionary principles in order to highlight the fact that, yeah, we don't know what we're doing, and we need to consider the resilience of the system before we break it further, instead of waiting for the techno fix. What does it mean in terms of applications and debating? There are obvious stakeholders to be considered on multiple scales. So on national and supranational governance actors, you have the UN, with the UNFCCC, with the COP21, with the Kyoto Protocol, and now the Paris agreements being driven by international institutional and international collaborations. You have the EU with the emission trading scheme and its climate policy, the 2020 goals for 2020, and of course individual nation states when it comes to the application of these. You can look at private sectors and the different corporations and how this might affect their profitability. You might look at energy research and how diversifying towards green energy, what it means for the companies that want to invest in that sector, the startups and the new research, but of course also what it means for companies in more traditional fossil fuel linked energy sectors. NGOs and civil societies with the Climate Action Network, WWF, Greenpeace, things like effective altruism, where the question is asked, okay, what is the most efficient way to save the world, basically, by what metric? But also civil society actors like world religions. Do world religions have a role to play? Do they have a moral obligation to do so? Are they in a position where they have a mandate to do so? And of course, when you want to break it down to the individual level, what does the climate change mean to Joe Schmo from the street in terms of cost of living, availability of goods, job opportunities, cost of gasoline? All of these things are useful to consider, and I would recommend actually that you would have, as part of debating, a list of common stakeholders and try whenever you get a motion, okay, how would this stakeholder react to this motion? Are they relevant at all? What are their interests? How do they take, what are their drives? What, do they have a mandate to act in these scenarios? And, this might be obvious to many of you, these actors ought not to be considered isolated from each other. Every actor is linked to another. There might be interdependency, there might be sector interdependency because of certain interactions between the political sphere and the economic sphere, because of multi-level effects where, you know, supranational or EU institutions might have a feedback process with the nation states, especially now with the climate of Brexit, etc., where you have nations maybe saying, you know what, if the EU says we can't do this or we shouldn't do this, who are they, etc. So considering the climate, considering the interactions between the actors, is that a way to get your arguments and your analysis to go that little extra step further. The arguments and the material for ecological issues, they're not necessarily restricted to motions that are explicitly about ecology. You can bring in a lot of this analysis as useful extensions, as useful considerations in economics motions, in IR motions, showing why, you know, the resource dependencies on certain countries make for relevant arguments, how the use of policies, top-down policies from the EU might affect, you know, the climate commitment from different actors, how, you know, Trump being president is even more of a problem now because we have a situation where he put a climate change skeptic or denialist as the head of the Environmental Protection Agency. You can even say on the motion which you're about to have in a few tournaments that this House believes that democracy has failed, that yeah, it has failed not because Trump got elected, but because as a democracy we failed to take significant actions about ecological issues. So be creative about how you use these arguments. Lastly, a few obvious cases. So from different ideological leanings as to how to frame the issue of ecological protection. Because ecology is not necessarily something of the left wing. Conservative can have strong interests, strong ideological narratives linked to preservation, to purity of a nation. So you don't always have to go for, you know, the opposition to the excesses of capitalism, but you can go for the value-based analysis of preservation as inherently positive for the nation, for example. You can go with the market liberal leaning when you say, okay, this is a growing sector, we can have a healthy economy if we move first and be the pioneers in this field. And but you also have, shall we say, non-standard argumentations with, for example, in the case of Ecuador or Bolivia, nature being given sacred rights as an entity in and of itself. So independently of the fact that, you know, we live on the planet, we might want to protect it, they said, Mother Nature has rights in and of itself, even if it damages us as human beings, even if on the long run we would actually not get any benefits from preserving the environment, nature still deserves to be protected as a unit, independently of our interests as human beings. On the opposition, even on the left, you can have lines of argumentation. As mentioned before in the case of Nicaragua, the idea of climate imperialism, or the narrative that by preventing access to certain types of technologies, we are preventing growth and development in certain countries, therefore keeping them subjugated to, the major players in the status quo. You can have also the classical conservatives cases with, this being diversion of resources, and we need to care about bigger and better things to keep the country strong. You have the market liberal leading where, any intervention, any restriction on the economic development is, illegitimate. There will be self-correction if the people care enough about it because, externalities, etc. and so on. And also the realpolitik aspect of, okay, we don't want to alienate our allies, we are dependent on these resources, on these types of economies, and we need national and international stability, which means that as much as we'd like to protect the environment, we actually can't right now because of a first mover problem, where if you're the first to move, then you have a trade deficit or a trade disadvantage, or you are more vulnerable to oppositions within your own country, etc. So you can go with value-based argumentation, you can go with fact-based argumentation, or you can go with just the pragmatic sides of, yeah, this is all a good idea, but in practice it doesn't work.